Hello, everybody. Could I get a quick mic check for me and Corey? Corey, want to say hello? Hello. Before
Hello.
we
Okay.
speak into the void too long, could we get a thumbs up that people can hear us? I've made that mistake too many times. Thank you. Hello, Justin. Great to see you. All right. Well, welcome. So I'm here with Corey Haines, and we are going to be digging into all the fun testing goodies, shiny things, and we've got a lot of fun stuff to play around with. You want to say hello, Corey? Thanks for joining.
Hi.
There you go.
Excited to do this. This will be a lot of fun. I've not
I'm excited too.
done much um, like snapshot testing or whatever approval testing that it's
It's a
called.
it's a really interesting practice, and not really something that we have a proper framework for in Elm. So one of the things that we're going to be getting our hands on today is just this like proof of concept little Elm snapshot testing setup I've got, which is just using Jest under the hood. Jest has like some pretty, well maintained snapshot testing infrastructure that we can
Okay.
leverage. And I'm pretty much just under the hood calling out through a port to Jest, and and then we get to write some snapshot testing in pure Elm. Oh, and I neglected to delete our setup because we are going to start with a clean slate here.
Excellent.
Clean slate. But fortunately, the audience didn't see that because they can't see our screens right now. So,
Oh.
so that's good news. So, as far as the audience knows, we always had a clean slate.
You
Oh,
always had a clean
Urine is accusing me of cheating. Um, so what we're let's introduce a few of these concepts, maybe. Um, so first of all, let's let's actually share the screen real quick. And since we're like dealing with a lot of different concepts today, let's just introduce a few things. Um, so we are doing legacy code refactoring with the Gilded Rose Kata. We're doing snapshot testing, and we're doing TCR, also known as test and commit or revert. So, Corey, you wanna walk through maybe legacy code refactoring a little bit and tell us about like some of the core idea and some of the basic practices?
Well, the first step is kind of to get things under a umbrella of tests.
Mm-hmm.
So I I always have that phrase that if you don't have a test suite, then you're not refactoring, you're just moving shit around.
Yes.
And so what we want to do
Mm-hmm.
is start off by making sure that we have coverage. Now we only really need to have coverage over the place where we're going to refactor.
Mm-hmm. Mm-hmm.
Because a lot of times when you come in with a system or a team that doesn't have test coverage, the first sort of panic in everyone's eyes is, oh, I've got to get my system under test. That's going to take too long. This is never going to work. But when you realize you just have to have the piece that you're working on right now
Mm-hmm.
under coverage,
Mm-hmm.
so we can slowly do that. And
Mm-hmm.
then it's a matter of going in, and since we are refactoring, we're not really looking necessarily to add stuff. We're looking to sort of clean up the code. And that can be a good introduction to get things under test so that we can start adding new
Mm-hmm.
features.
Right, and it's probably worth noting the goal for legacy code refactoring, as you said, you don't want to just move shit around. You want to capture the behavior first, and that includes potentially bugs. So we're
Mm-hmm.
characterizing the current behavior rather than the ideal behavior, and that's an important note. So, like
That is.
So whatever the current code does is right by definition. So for characterization testing, that is the definition of it, right? And that's like a very freeing idea, that you don't have to get caught up in what should it do. It's what does it do, and you want to make sure that your tests capture that. Another.
Yeah, and another.
Yes.
I was just going to
Please
chime in and say that one of the goals of doing refactoring on a legacy code base is there's the idea that if you want to add features, but it's hard to add a new feature, the first step is to refactor your code so that it is no longer hard to do the feature. So it becomes really easy to make the change. So then you can make the change with the caveat that refactoring could be hard.
Right.
But getting it so that we want to get it so that the hard change becomes easy via refactoring.
Right.
Where the refactoring can be hard.
Yeah, that's one of my favorite Kent Beck quotes that I repeat all the time. Make the change easy, then make the easy change. Warning, the first part may be hard.
Yes, exactly.
And that's what you want. That's a sign that you're doing it right, is that the change part is really easy. The making the change easy part could take a while, but that's fine, because those steps are a series of safe changes. So that's the part that you want to be hard, is the safe part. And then the unsafe part should be easy, which actually is very much a good description of Elm, actually, now that I think about it. The really hard parts are safe in Elm. Elm makes a lot of the hard setup stuff a lot safer.
Well, it provides you with a core set of tests already, which is so you don't have to write a lot of those. It already gives you an umbrella.
Right. Right.
Certain tests.
And then, for example, like side effects are easier in JavaScript, but in Elm you treat them more carefully. So it's a similar philosophy. So for code coverage, we're gonna often people look at code coverage, I think, as like a score, like what score did I get on the test? I got an 80%, I got 100%, right? And they're like trying to get 100% score. And I think that can really lead to it's a poor metric for the quality of your test suite, because that shouldn't be the goal. The goal should be confidence in your tests. There are so many different facets. Like, there could be a whole discussion on this, but suffice it to say, be very careful about like putting a specific number as your score for how good your tests are. But that said, code coverage is very useful for just gaining insight into, like, if I'm not even hitting this, I should probably think about writing a test for it at least. So we're going to use it today for insight rather than a score.
Yeah. And I think of code coverage not as the code coverage number is not the important thing, but the change. So the derivative over time, so that how the code changes over time, that should be positive. And if it turns negative, it doesn't mean that you made a mistake. It just is a flag that you need to consciously allow your code coverage to drop. And so that it's more of just like, hey, is this okay?
Yeah.
Which is really what testing, all of this stuff is not set in stone. It's just guides. It's that little friend that follows along with you while you're coding.
Yes. Exactly. It's like increasing your awareness, and it's a tool to help with your awareness, not your score. Cool. So there's some things that we're going to be thinking about as we're doing our legacy code refactoring. We're going to do it on something called the Gilded Rose Kata, which I don't know. Let's maybe not get into the details of that right now, and partially because we don't we don't necessarily need to understand what the code is supposed to do. In fact, a lot of the time when you're dealing with legacy code, you don't know. So it's okay. You don't have to understand the code. You can look at it and try to figure out, we can use our test coverage, we can use these different tools to sort of understand the code through writing tests rather than understanding the code so that we can then write tests.
Yes.
Yeah.
This is where your snapshot testing stuff comes in.
Exactly. So snapshot testing, we're just going to be feeding data in, capturing what it currently does, and then we're like, so again, whatever it does right now is right because it's a characterization test, not what it should ideally do. There may even be bugs. We want to capture those current bugs so that we can refactor. And if we want to deliberately then decide to fix those bugs, that's fine. But we should understand when we're changing them, not just, oh, I refactored and a bunch of bugs went away. We want to know when we change it.
Yeah.
TCR, this one is really fun. It actually, so Kent Beck was doing a workshop where he was, teaching some testing practices and stuff, and he was teaching this practice he often does where he, as he's refactoring, he'll run a watch loop over his code and just run the tests, and if they pass, he just commits them. So we can just refactor and keep committing the code. But if the tests fail, it doesn't commit them. And then one of the workshop participants said, well, by symmetry, shouldn't it then revert the code if it doesn't pass? And he said that he hated the idea so much he had to try it, and now he's become a big advocate of it. And it turns out the workshop attendee who had that idea of TCR is actually an Elm developer in Norway. So that's kind of a fun little background. I met him at an Elm conference a couple years back. So we're going to be playing around with this idea. And if that's not enough fun, shiny testing stuff for you, then I don't know what to say. So cool. So keep in mind, again, this is like a proof of concept test harness, but I think that it's pretty promising, and I'll be curious after like getting some feedback and playing around with it more to perhaps turn this like snapshot testing stuff into like a more full-fledged framework. Is this
so
Oldmund?
Are you
hey,
snapping?
Welcome, Oldmund. Nice to see you.
Hello.
Talk for sist. He's Norwegian, and I'm part Norwegian. So now we can start having some fun. So let me get our TCR script running, make sure it's happy. Okay, so now let me show our coverage report. This is what that looks like. So so we can see exactly which lines are being hit. And we can use this as a map of our cases that we're definitely not testing. Now, hey Ryan, how's it going? So we cannot conclude by seeing that a certain line is covered that it's fully tested, but we can conclude if a line of code is not covered, then it's not being tested. So we're going to use it to figure out what we should test. Yeah. So
that statement reminds me of when I shifted over to do Elixir and was using their typing, and it's success typing.
Oh yes, that's right.
And it's such a difference where like the tiny Milner says it's right, and the success typing says it's not.
I can't prove that it's wrong, so I guess you're good.
And it threw me off because I was expecting it to actually catch problems, but it rarely caught problems for me.
Yeah. Exactly.
Or I way overused it because I was actually using it as more of a type system.
Right.
It was more like a check, a little bit of verification. usually think.
It's definitely a bit of a
Okay,
letdown.
so
Yes. So yeah, what?
so red means it is not covered. Green means it's not necessarily not covered.
Green means it's not necessarily not covered. Yeah, that's fair. That's totally fair.
Okay. Okay.
Oh, Aaron's asking, is this a structured Elm editor? This is just the report that we get from Elm coverage. I would actually love for this to be a format that I could consume to have the editor highlight this, but right now it's just an HTML report, which is cool, and you can see all these metrics, which is quite nice. It works great. This is just Ilias's Elm coverage library, and Ryan was asking, is this the example from Richard's talk? Yeah, Richard did a talk where he talked about gilded rows in Elm. It's like a kind of classic legacy code refactoring. God, it's super fun.
Oh, Aaron's talking about this. Okay, let's not get distracted.
Yeah, so let's pick a test case here. So what should I add for a test case?
Well, Phil, I'm uncertain how to get started with snapshot testing.
Okay.
Like what do you mean? Like I would, so how would you go about picking test cases for the snapshot? Because
well, since this is a pretty cheap thing to test, one way we can approach it is just throwing the kitchen sink at it. So, for example, we can just notice these cases and say, well, we can add something that has this name. We can add something that doesn't have this name until we're covering these cases. And we can also use a tool for extra confidence that I've built into this, which is we can do verify all. So we can actually the output may even be the same. So this may be a refactoring change here. If we do verify combinations and turn these into lists, then that's just green.
wait, what's that failure now? So what is this? Because what is the output here tell me?
This is just a git
just
diff.
a diff? Oh, it's just a diff. Okay.
Yep, exactly. Whereas if there were no git diff, it just wouldn't have any output or anything.
Okay. What's happening?
You were getting bigger and then smaller. Well, all right. It seems okay right now.
Not like this.
Yeah, exactly. Exactly. Seems okay now. All right. Okay. So cool. So yeah, what this is going to do is for every single value we pass it, it is going to it's going to do the first argument, and for that argument, it's going to do each of the values from the second list. And for each of those, it's going to do each of the values for the third list. So we're basically building up a straight up truth table. I don't know if you ever think of test cases that way. Sometimes I like to just, write out like backstage pass, 0, and then it's going to do backstage pass 1 for each of these things we pass it. So let's pick one of these things. So for example, we could just grab this guy and pass this in. So it's going to test this permutation.
Okay. Uh-oh. Oh, that's a good fail just means we have a new snapshot.
Yes, right, exactly. So we're, snapshot testing in combination with TCR is sort of interesting because it's not reverting, right? But it's updating the snapshot. So we want to be able to update the snapshot in order to add test cases. So add case. Okay, now let's see our coverage report. rerun our coverage.
It shouldn't change because we haven't updated quality.
That's right. So we need quality greater than 0. Should we do that?
Yeah, okay.
Well, I can think of a number that's greater than 0. Let me first, what do you think of giving these some names?
Yeah.
Name, cell, and quality. Name. Rename. So this is sort of the flow with TCR. Reformat. Was this cell in? Yeah.
Yeah.
So again, this is so Corey and I mean, we happen to know this problem, but even if we didn't, we could follow the same process where we're just like looking at the lines that are being hit, looking at the names of these things, and sort of not fully understanding the code before we proceed to try to get it under a test.
Yeah.
So we've renamed it. So we said we wanted to have a quality, which is the third one here, which is greater than 0. So let's try 1. And it should tell us that it gives us a new snapshot. So there's the new test case that we're capturing. Add quality 1 test case. So now it's doing that for both of these names. If there were multiple cellins, it would do that for multiple cellins as well. Now let's take a look at our coverage report again.
Can I make a feature request for your?
Oh yeah, absolutely.
Thing? Hide that failure for the snapshot.
Yeah.
Like separate these out because that's.
Yep, totally.
I keep seeing that. I'm like,
Yeah, I need to so rerun on pass, right? Or after rerun after checking in new snapshots.
Well, just don't show me because I don't actually, like, instead of showing a test failure that the snapshot changed, just make a mark somewhere, like say snapshot changed. Because this right here, I'm confused I keep getting confused as to why we have a test failure. Because it seems like you're using the fact that, like this right here, your expectation. You can't see my cursor.
No.
Can you?
But
okay. That line 18 through 20.
Yes.
In that.
Oh yeah,
code,
that should totally be
hidden. And you're using the fact that you got just underneath in order to trigger. I need to resave snapshot.
Yes.
So that failure then ripples up and confuses me because I see a test failure.
Yes.
So I wonder if you could catch, like right there on line.
Yeah.
19, maybe catch the test failure and trigger because you're. So when you because you don't actually have to have a failing test right there.
There is actually a way. So yeah, it's right.
You're just using the failing test as something.
Yeah, it's interesting.
As like the event.
Right.
Right. Sorry.
Oh no, you're good. You're good. So there's actually the way I'm doing it right now, because it's just like the low level details of like the jest setup. You can have like an asynchronous test in the test case, but you can't have asynchronous code in the test setup. And for that reason, I'm only running a single jest test case. If you run it as multiple test cases, it will consider a new snapshot to be not a failure, which is interesting. But Yeah, I definitely need to refine this. What I'm one of the directions I'm thinking of going in is like doing code generation to have more control over how it does some of these things. But it's kind of it's kind of fun to be able to just like play around with the flow, with the proof of concept, and see go from there. But there's definitely a lot of refinement. So yeah, we've got we're hitting both of these cases. Let's see, and so what should we do next?
Well, we could make some refactoring, or we could cover a little bit more of the code. Like we have a chunk of code here that looks interesting. Also, I'm bothered that name is a string and selin and quality are ints.
That name is a string and selin and quality are what? Are ints?
Are ints.
That they're not. That they're not types.
We've
that we
already.
Yeah. Differentiate.
It already bothers me.
Right. Right. Well, what do you think of trying to get all green, which we can pretty easily do, and then diving into refactoring?
Great. Sounds good.
Okay, cool. So what green should we go for next? What red should we make green? This one?
Sure.
So
we'll just go down.
Else if quality is less than 50. So we're checking the conditional, and it appears to not be else if quality.
But we need name to be aged free.
Yes, if the name is not aged free and it's not backstage pass. Cool.
So to even hit this line, we need to do it.
Mm-hmm. Cool. And the cool thing is we can throw a bunch of stuff at this. Okay, so let's try this guy. We've got a couple new test cases.
Yeah, I like this. I like this output that shows me the new test case.
Yeah, right.
But if you just had that would.
I know that would be totally. Yeah, I can get more fine.
I'll stop harping.
No. I appreciate the input, and that's one of the reasons why I wanted to. This is really to play around with this like proof of concept tool. So I definitely love getting feedback on it. It's at the stage where I'm ready to like turn it into something more than a proof of concept, because you can actually kind of use it a little bit. Okay, so let's run our coverage report again now that we've got aged brie. And sure enough, we've got more green. So that's great.
Great.
Okay, so if name equals this backstage pass thingy, it appears to not be, because we're not hitting these lines. So let's try that. I add the quotes when I didn't copy them, and I don't add the I always do it in the wrong places. All right. Add backstage pass cases. And let's rerun our coverage. So you can see this is like getting, like there are several steps that could be automated here. Like it would be nice if we didn't have to manually rerun the coverage and stuff, but we've got the makings of like a pretty nice workflow here. Okay, if quality is less than 48, so it appears that if selin is less than 6 and quality is less than 48. Oh wait, if quality.
Okay, so let's make quality bigger than 48.
All right.
So 49.
That sounds like a great idea. Quality 49. All right. Cool. And check out our code coverage. Okay. If the quality is less than 48. Oh, if the selin is less than 6, then do this. Else. So selin
Wait a minute.
greater than
Okay.
6.
Okay. We're not ever going to be able to hit line 43.
43.
Because
Oops.
quality, if it is, oh, it's got to be 48. Set quality equal to
Equal to
48.
48. Okay. 48.
And that should catch this 0 on line 43.
Let's see. Line 43. It does.
Yeah.
And then if we add a selin that's greater than or equal to 6, that should capture that line. Let's add 6.
Oh,
Okay. Rerun our coverage. All right. Progress. Now, this is the else for if selin is less than 11. So let's try selin 11. Get this guy green. Kind of a, we're getting into the zone a little here. And notice, so notice that we just added one case, right? And we've got 1, 2, 3, 4 for Sulphurus. We've got 1, 2, 3, 4 for Backstage. We've got 4 for Aged
should
Crew.
add like 16.
Yep, exactly.
Combinatorial
Explosions. Which could be a problem in some cases, but in this case it's not. So we're just doing it.
We need some buzzers here. That's the thing that I'd like to see, because we're picking very specific cases, but I would love to just say send in 1 through 100.
Yeah.
Because we're not putting in things like, we're not covering things like 7.
Right. Yeah, that is a really interesting, I guess it's really interesting with fuzzers, because with one of the really convenient things about snapshot testing is that it allows us to just very easily do a characterization test where we don't have to manually characterize it. Whereas with a fuzzer, we'd have to figure out which characteristics we wanted to assert it had by actually writing code to assert that.
Yeah, so I think rather than the fuzzer is more of just generators. Like the fuzzer part really comes from the shrinking, whereas it's, a fuzzer is a generator plus a shrink. So we really just want that generator, so I could say like run this over integers. And we can. Right. Let's take this and make this a list that's a range from like 0 to, we could go look and see what's sort of the largest number that there's any space.
Yeah, I like it.
Talk about. So for quality, I think quality it's like 50.
There's 49, so yeah, so up to 50. That sounds good to me.
Yeah, so let's do that. Let's do a list
Love
range
it.
there.
Love it. So list dot range.
Yeah, that's
from 0 to 50.
Yeah.
Love it. That's great. Great idea. Now that's going to be a combinatoric explosion. That's what I like to see.
Yeah.
Look at those test cases. I mean, really, why not start at -1?
Sure.
Because that's an interesting one too. Because it's really what's nice is to, for this specific example, if we just take the interesting numbers and then do like plus or minus 1, test that range, then we're going to be pretty well covered. And so again, we don't really care what the specific output is. We're just trying to characterize it. So we're taking a snapshot of when we feed in these inputs, let's capture what it gives us. So, yes.
A really interesting thing about TCR that is regarding the commit message.
Yeah.
Because what the log does is it shows a running narrative as opposed to what we're used to with commit messages, which is we talk about, like, we often say your commit message shouldn't say what.
Yeah.
It should say why.
Right.
Whereas with TCR, you have this long stream of what, and then when you're done, you can squash them all together and write out that why.
That's interesting.
And I like that flow.
Yeah. That's very interesting. One thing I often think is that I almost wish that like automated refactoring tools would have a built-in commit message creator that would just say exactly what the rename was. Renamed function foo to bar. And just as part of the rename refactoring, it just, boom, creates a commit message. Because that's a safe refactoring. If it's a guaranteed safe refactoring, just commit it, and you know what I just did, so give me the text for it.
Okay. Let's put in a name that is not. So let's see, a name's not aged breed, not backstage passes. So, sell-in. We need to deal with sell-in.
Sell-in of, yes, less than 0.
So let's do a list range on sell-in.
Nice.
And let's do this like a -1 or whatever.
250? We can.
Sure. Yeah.
Why not?
I mean, I would usually go into look at the code and see what is the largest number
that's interesting.
That's interesting.
Yep.
But we could do, like Aaron suggested, just min and max it.
We could. I wonder how. I mean, we could try it.
Timing-wise, it might happen. Like it might.
Yeah.
I mean, it seems fast.
It's pretty fast.
But it's running that many tests, so we're now going to be running. That's quite a bit larger.
Ooh, look at that! Okay. All right.
So we covered everything.
Boom. So we can. We are hitting every single line. And since we're doing. Here's the thing. We're checking. This is just a bunch of if statements. And we're doing a range of all the numbers it possibly finds interesting for all of the values that it cares about. So I actually have pretty high confidence that we have, that we cannot break the code without breaking a test right now, which is very rare.
Let's try.
All right. What you want to suggest a possible break? What do you think could break this?
Well, let's go into the code and let's change one of these numbers. I don't know. Let's change one of these numbers way down here. Let's change this 48 to a 47.
Sounds good. Oops. 47. That's the Star Trek number. They sneak that into every episode they can. So this changed the results.
Okay.
Enjoy the confidence while you can. So that gave us failure.
Where do you see that? Because all I see is that our snapshot changed.
Yes.
So, but it should have failed. Like this should revert, right?
Well, I mean, with snapshot
Sorry.
testing, if you want to change the behavior, you have to have a way to change the snapshot. So the way I have it set up is it gives you the option to commit the snapshot change if that's what you intended. You could approach it different ways. You could have it so that the
Oh, so it's not, I see. Okay. So it's not sort of a two-phase, let's build up snapshots and now let's start working on tests. It's everything is always going to tell me the snapshot changed. And then in my mind, I have to say, I didn't expect the snapshot to change.
right.
So I'm to hit escape here.
Yeah, exactly. And I'm
Or
curious what Odmund thinks of this, but this is not your like textbook TCR flow. This is sort of a modified TCR snapshot flow. So we're giving.
Well, I think what I'd like is a way to. I'm sorry.
No, you're good. You're good.
But what I'd like to see is a way to say freeze my snapshot.
Yeah, I totally agree. Yeah, it would be cool to have like a modal sort of experience where you can. Well, maybe that's like a. Yeah.
Because in my mind right now, I'm not.
You want it to just revert it without asking you in like refactoring mode.
Basically. Yeah, I want it to just say your test failed.
I like that idea a lot.
But I see what you're
right.
But I understand now.
And that's just the specific way I've set up these like scripts and Apple scripts. There's it's but no, these details are really interesting, and they change. Like the thing that I find really cool about TCR is that you build a different like visceral relationship with the tooling. So there's a certain feeling that you see. If you do TCR where it just auto commits without you entering a message, it's actually even more of a visceral feeling because you type something and you're like, did that work? And then you see the diff go away and you get a little dopamine hit, and it's like a visceral feeling, It's a really nice flow.
So how come? Okay, great. So it reverted. I see the 48.
Oh, let me just read out Odmund's messages here. He's saying, I think everyone actually trying to use TCR has their own scripts held together by duct tape and pragmatism. Totally. I don't think the textbook for TCR has appeared yet. Yeah, totally. These are just like a set of principles to play with to your own needs in a pragmatic way. I think that's a great way to frame it. I like that.
Yeah.
So what were you saying, Corey?
Oh no. I was like, okay, so we've got a reasonable confidence now.
Yeah, totally. Okay. So should we dig in and start refactoring?
Yeah.
What catches your eye here?
Well, there's a couple things. One is I would like this. Oh, you still can't see the cursor. I would love item to be a little bit more, I guess, well typed.
Yep.
And so like
I don't want something like
that.
Like, was this what you were saying? You want something like this?
Yeah, I would love something.
Awesome. And this is actually a perfect example of TCR. You commit that. Did it change anything? No, it's not being used. That's fine. Just commit it. There it is. If we decide we need a different type, that's okay. No problem.
And this is something Aaron said earlier, is what if it also hooked in and removed all unused code?
Oh, that would be cool. Would be cool, although it would also break in certain cases because in order to not break things, you need to... You often want to introduce an unused, like a function that's not used, before you start using it.
Do you?
Well, Kent Beck does it
because
that way sometimes.
So you can go through and say, I'm actually just going to write the code in the test and then extract the function from your test code.
Yeah.
So you can actually do that where the way that you never have a failing test is that you build your test that has the code, and then you extract it out of your test. They extract into your test module, then you extract your test module into your production.
Interesting.
So you can go through and do it.
Yeah.
Like my first thing, rather than building this type, would be to come over to, I would move into microtest now.
Okay.
And I would start building a function called create item.
Yeah. Well, we can do that.
Yeah, we could do it, or we could, we could just here say, I am going to, let's start a function call. Well, we're not going to be able to cover that function. And this is where, we had talked yesterday about this idea that these cover, this gives you a replacement for microtest.
Yeah.
And
right.
I disagree because I could say that update quality item is the thing here. But I would love a function called create item. And that takes a string and 2 ints and returns me the opaque item type.
Yeah.
And then we can here incrementally do it. So if you took and get rid of 17 and 18, because let's take very small steps. That's that feels to me like a very large.
Okay.
Instead, let's come over to our snapshot tests.
Yeah.
And I would put a function on line 5 called create item. And it takes a string, an int and an int, and returns me an item. And that should be line 16.
Hopefully Intellij doesn't try to save. There we go.
Okay, and then line 17. So what I'm doing here is I'm taking what you have in line 17 inside
You're
the
extracting
list,
that guy.
and I'm extracting that into a function.
Right.
Does the Intellij thing has extract function, doesn't it?
Not
as an automated refactoring?
It doesn't yet. That's one thing I'd like to.
Exactly, Aaron. That's why. Aaron, that should be.
Absolutely. Well, so yeah, if your automated tool has extract function, then that would be.
Let's hit escape here.
What's that?
Just hit escape here. I want to actually do this.
Okay.
Because we don't have to have an automated refactoring to do
it.
We can do it. So I would say get rid of line 7, 8, 9.
Okay.
And let's do the extraction. We can pull that.
So we can extract to let.
Excellent.
And that works in an automated way.
Okay. Now you could take item and change the name of item to create item.
Yeah, right.
And then slowly, now we can add the first parameter, which is name. Pass.
It's going to be unhappy about shadowing.
Okay, well, let's change the thing coming into the test to in.
Change the thing coming into the test to in? N?
The letter N.
Okay.
Yeah. And then we have to pass it in 16. Okay. Should be passing still. Why did it? Oh, it's at that diff now.
Yeah, yeah.
Anytime I see red, I'm just like, okay, so let's do it for sell in as well.
Cool.
So there's somewhere I have a recording of like building up this, doing this technique. But
Mm-hmm.
like, you just make the changes in your test code,
Mm-hmm.
and then eventually you then extract it.
Right. Yeah. Yeah, that's a great technique.
I don't know if I would say it's a great technique. It's a very pedantic technique.
Well, it's good to have in your
But if
toolkit.
you,
Yeah.
yeah, it's one of the things is if you make a change and you're not sure why it broke,
Mm-hmm.
take a step back and make a smaller change,
Totally.
and
Totally.
make a smaller change,
Mm-hmm.
and you pull back towards your tests to where ideally you only make a change in your test.
Mm-hmm.
So it is a good technique. Now we can extract create item.
Yes. Oh,
Haines,
create.
and now providing.
Oops. All right, there we are.
There we go.
Cool. Extract function.
Happy, Aaron? Yeah, if the tooling were less tedious, but
Oh, yeah.
I did all of this. I used to do all of this in Ruby,
Mm-hmm.
where Ruby and Vent, where I had no tooling for refactoring all there. But
Right.
having like an extract function that does these steps, because this is effectively what extract function does. Okay, now let's take create item, and what I would like to do is expose. Well, we don't actually. What I want to do is I want to copy it over here.
Copy it into here as the first step to moving it.
Yep. And so copying it. At this point, we are still like this is now unused code, so it would get removed. But this allows us. We can go back.
Yeah, it's like the Martin Fowler refactoring textbook, the manual refactoring steps. It's you create it and then
And so we could have made the change at Snapshot Testing for the rows to just. So now we want to expose it, and then snapshot test, we can reference that instead. And save it. I love that. I love this small.
Yeah.
This is my. It's so fun, like figuring out it's a puzzle.
I know it is. Yeah. Yeah. Exactly. It's like playing a little game.
Yeah. And so now, let's go back to gildedrows.elm and remove the item constructor. Well, you can. So you no longer need to expose the item constructor.
Oh, we do still need the type. Yeah. Oh, that did it. Cool.
Keep the type. We don't need. I would keep the type exposed.
Totally. No. You don't want to have. You don't want to have functions as a general rule. In Elm, you should never have the ability to create a type whose type is not exposed. Having constructors hidden is great.
Yeah. Okay. So then we can get rid of it on line 3. We don't have to import item anymore.
Get rid of it.
I'm sorry. In snapshot tests.
You
can get rid of on line 3. You don't need to expose item.
Cool.
Awesome. Okay.
Update, import. All right. Cool.
So now let's go back to Gilded Rose, and we can do one of your steps. So we know that update quality item coming in. So let's make name the strong type.
So now you're saying type selin like this?
Let's start with name.
Okay.
Just start at the left.
Cool.
Yeah, I would love to.
Nice to have a way to expose custom type variants only for use in destructuring. Not be allowed
Yeah.
for creation. Interesting.
Yeah, if I find that I'm destructuring a lot outside of the module or where it's defined, it kind of makes me feel like I want to have a function for doing it. So now we have 2 lines that we have to change now, but on line 18 and line 26.
Yeah, we've got to use it here. We need to change a few places, don't we?
So now we should only have to change it here. This is why we have create item. I mean, there.
Cool.
Now we could do it in even smaller steps.
Oh,
and have a function called get
I'm
name.
happy about this. We may have to. Let's revert that. So.
Yep.
Okay, so you're saying have a function called get name, which right now is.
See the place where we had to change it. Sorry.
Oh, we could have create.
Let's change these to be using create.
Create item, exactly. Yep.
That's what our problem. Not
there we go. Yeah, very nice.
And this is actually a really good example of the violating the 4 rules of simple design. Specifically, knowledge duplication. So Dry says that every bit of knowledge should have one in only one place. We were spreading the knowledge of how you create and how you construct an item.
Right. Which
we've extracted that in one place.
Right. Yeah. Yeah, very nice.
Okay, so now let's this is going to be fun.
Yeah.
Let's go down to
And
left.
by the way, just a note, the process we just went to where we hit a wall and then we backed up is like, that's the point. That's actually not doing the process wrong. That's like the process exactly what it's designed to do, is to like, you do a step and you're like, this is kind of feeling too big. What's a smaller step we can do? Revert, clean slate. Let's try again. So that's like, that's a sign that you're getting the benefit from this process.
Yeah, because a lot of times the motivation, or not motivation, but our instinct is to go in and change all of those places.
Exactly, yeah.
But changing all of those places is the opposite of stopping and going, wait a minute, I made a small little change, which is the structure of item. Why did I have all of these places fail? I would prefer to have one place fail, maybe 2, creation and then extraction.
Right, exactly. Because we're like, basically step 1 is we're creating strong feedback mechanisms. But then you have to then listen to those feedback mechanisms and what they're telling you. And right now it was telling us the step you're taking is too big. We listen to that, change course to a smaller step. So, okay, so what's our next step here?
Well, if we want to be really small, what we want to do is have a function that knows how to get the name from an item.
Cool. So one thing I sometimes do is like let it have this redundant item thing, which is telling us it should probably be in its own module. And then later, when you extract it into its own module, it just turns into get name. It's kind of weird having getters, but yeah. Well, I guess in Elm we usually just call them name.
I would call it.
Yeah, I like that more too. Yeah, it feels too Java-y, right? Yeah, this is great. I really like this progression.
And here we can destructure here.
Whoops. Yes.
No. an item, yeah.
Item
So we can just structure.
name, we don't care. And that actually decouples us even more from those details, which is kind of nice. If we do change those, we have less places to change.
And then line 22, destructure name as well inside here, because that's not a string.
22.
Oh wait, it still is.
It still is a string, but it's
haven't made that.
We just
we're building up so that we can make
right. We're making the change easy. Yeah, great stuff.
Yeah.
Great stuff.
Okay.
How am I not following? What the hell? Oh, are we making things confusing? So what we're doing is we're setting it up so that we can change. So we can use this name type. So right now we've got this name type, but it's currently a string in item. And what we want is we want to use this custom type, but we're trying to make it so that we have to change fewer things at once. So we're doing some preparatory refactoring so that when we do, it's decoupled from the implementation. So we'll have to change it in fewer places. So we're taking like pedantically small steps, which is what we're trying to do here.
And I would probably, if we jump up a little further, or go back to the signature.
Ryan meant on Twitch. Sorry, what was that, Corey?
Go up to the signature.
Item name?
Rather than item name, let's have a function called, or have item name. We can call it item name for now. Actually take a name and return the string.
Okay. Okay.
Take a smaller. Aaron, it'll swing back around. Name probably doesn't matter. The two ints do.
Yeah. Yeah.
I do want to have those.
So we don't mix them up, or we can guard against those types being passed in.
Yeah. So what I want to do is it's actually going to take. Okay.
Revert.
Yeah. So the problem is you jumped ahead and we have this name type that is unused. The line 12 and 13. I want to make it a type alias for string.
Sounds good.
Because I want to use it.
Oops.
And I want to actually use it in the type of item.
Okay. There's one step. Use type alias for name. And you want this to, given a name, which is currently just another name for string. Yep.
I want to change line 9 to be name.
Oh, okay. Should I revert this guy or should I commit this change? Revert.
I would just delete the item name function.
Sounds good.
Because what I want to do is I want to write a getter for name. And then, no, that's not a name. That's not name. It's line 9. Line 16 is our
Gotcha. Oh, yes. Cool.
Because now I can write a function that is get name that takes a name to a string. And it's just identity right now.
Right.
And it's really toString for name.
Right.
But yeah. Okay. So at this point, we have this function that knows how to pull out name. And so on line 31, I'm going to change that name to like n. And I'm going to create a function in my let clause name.
Like that?
Yep. And so now all of the code is using that.
Right. We've just removed that dependency there on the direct.
Yep. And so we can play around all of them.
Cool. Great.
And then we can eventually remove that and destructure on line 31. But we can't destructure, like, that's a big step to change the type
Right.
structuring.
Right. Yeah.
So what we want to do is now we can actually since we're taking super small steps anyway, I'm gonna swing back around. Let's build a function called create name.
Yeah.
We're gonna delete this once we shift out of an alias, and it's just identity as well. Okay, and now let's use it in line 28. So it's item, and then we want to create the name. So now we've taken and abstracted it way out, and so all we have is the creating get. So we can make those changes. We're going to have to make both those changes. We have to change in those two places.
Right.
But the only places where the type alias.
I feel like a lot of work could, Aaron's saying, I feel like a lot of work here could be avoided if the language allowed any value to be tagged with a purpose that would participate in the type checking.
Say more. Right, a little bit more. So let's change this to a type, to an opaque type. And we're going to have to change our getters and create.
And then it's compiling.
It's still pass.
Oh, yeah. So this is what just changed here is the underlying types, which is interesting. So the my test helper here is actually just doing a debug.toString on the type. So now it has this name type. It's off the screen here. You see?
Oh, I see.
So
why? Where? Show me again. I don't understand where that. Where are you storing that?
Right here.
But you shouldn't be. If you go back to the snapshot, create item, update quality returns that. I see. So I think this is a case where we update the snapshot.
Yeah, I think that's reasonable. If we really wanted to, we could also manually decouple the representation. But I think it's reasonable to update the snapshot.
Because the problem is that our snapshot is not independent. And it doesn't know about. We would have to write like get this and that. Okay. Yeah. So now we should be able to go up and delete those get and setter, the helpers around name, because we already have create is just the name constructor. So let's 21. Basically, we want to inline 22. So we want to inline this function. So line 28, that's just name. Oh, are we not? We're not getting our.
There we go.
Your console is wrote back.
Okay. Now I think we're good.
And now we can actually replace get name on line 34. No, not there. Line 34.
Okay.
Because you're not going to be able to do that because of the shadow. So this should destruct. You should be able to destructure.
Name equals.
No,
I have to do a case statement.
Line 33. No. Line 33, you could just wrap it in name. So destructure there. Yeah. And then you get rid of get.
I don't think so. I think it has to be a case.
Yep. Nope. Get rid of get name on line 34.
Get name.
So it's equal to end.
Oh, nice. I've never used this.
Because what you're doing is so name is a function.
Mm-hmm.
You can destructure as you're coming in.
Oh, of course. Mm-hmm.
So now we can swap. We can get rid of get name.
Is it unhappy about got stuck trying to parse?
Wrap it in.
Is this do I have to do this?
Yeah, I think so. Yeah. No?
No, it's happy. That's just our diff. Yeah, we're good.
Oh, okay. So now we can inline n. Yeah, get rid of get name.
We've got a comment. If I was doing this, I think I would have taken the module interface as unchangeable. Yeah, that's
what has changed in the module interface?
Well, I think maybe the point is that since whatever was exposed in the beginning, we can't change anything that had been exposed. Like basically, if this that's one way to think of it. Like basically, if this had been an Elm package, you could say that the semantic versioning should not have a major change based on the Elm package. Okay. That would be one way to do it. I think
I would have added a new type.
Mm-hmm.
I would have copied and did a extraction like this.
Mm-hmm.
So what I would have done is I would have had a new type of item.
Mm-hmm.
And then this update quality item would have delegated to my other one. It would have wrapped whatever it needed.
Yeah.
And then delegated.
Right. We could have a get item type thing that returns the old type. There are a number of ways to approach it. Yeah. But these are all, this is all just a learning exercise. And I think whatever real world.
I also wouldn't have.
Mm-hmm.
Yeah. I wouldn't have coded this way.
Yeah.
This is okay. Well, let's move a little bit. So let's get rid of that name.
There's a question: has the test coverage changed at all? It has not. It has not changed. Get rid of.
So now we can inline name. So n is we have no longer a need for that temporary variable n.
Yeah, and these are all steps that would be a little more fun if the editor did it for us, which hopefully we're getting there.
I kind of see, the thing is, I like doing this manually because it's
mm-hmm.
in an exercise like this, I enjoy doing them manually mm-hmm. more than having a button that does extract function, because mm-hmm. it exercises that part of your coding of do you know how to do this? Can you do this? We made these incremental small changes and introduced an opaque type for name,
mm-hmm.
or introduced a strong type for name.
Mm-hmm.
And we can do that so now we have the exact process.
Mm-hmm.
And quantity.
Right. So we can apply that same type of thinking to other creative steps to break things down into tiny little steps. Yeah, that makes sense.
Yeah. No, it did not. The snapshot change did not point out that the interface changed. The snapshot, it is a problem. The interface is still item comes back.
Yeah, the thing that's passed in didn't change.
No, the thing that comes back from update quality items.
Yeah.
So up the type
Yeah.
signature of update quality did not change.
Yes, right. Just the internal representation. But our snapshot test is capturing the internal representation because it's doing debug.toString. Which there are other ways
Yeah,
to do it. If we wanted to, we could have a custom formatter. We could have a custom toString, and that would be a way to decouple the snapshot test results from that.
yeah. So I disagree that the snapshot result or the snapshot implied a change.
Right.
The module interface, we have changed the module interface. We changed item to be opaque. That's the major module change.
Right.
Or module, but.
Right. Which these questions are all hard to answer when you're not talking about real world code, because you're like, well, why can't I make this opaque? Like, what consequence would there be? But in general, it's very nice to be able to use these opaque types because you can make more guarantees about the data.
Yeah.
So
making a change like this in production code, that like in a package, Aaron brought out is rough. Yeah. So the module changed, the module interface changed, but that was not what the snapshot change was not because we took out item, or we took out the item constructor,
right,
and stopped. That's not what caused our snapshot.
Right. I guess the question I think that Wonderful might be asking is like, if the purpose is to do a pure characterization test and then pure legacy code refactoring, can you change the public API? And, I think, again, it's like a pragmatic question. And like, if you have all of the code in your code base and you can see that it's a non-breaking change to hide the constructor, so no one was directly using it, or if you go and change all the places that were directly using it to use your new create item function, then that's fine, right? It's so
you would ripple it through, and you would ripple the create item through the rest of your code base.
Right, before you change any internal implementations and stuff, right? So it wouldn't be breaking change.
So it depends on what your
goal is, and
what your goal
case.
is.
Yeah, exactly.
And we're doing like I would say that this is not a very great way to program, making these really tiny small changes. I would make some large, like right now, we could make a couple large changes that mimic those small changes and do sell-in. Like, we know what changes are necessary to make sell-in strongly typed.
Well, do you want to try that different approach and see how that looks?
Yeah. So let's write a type for sell-in. Don't save it, because we're going to have to make a bunch of changes that at this point, whenever we're about to change the type signature of item.
Right.
So we're going to go through and make a bunch of a couple large changes.
Right. And it's also going to change our snapshot output. So cool. So should we
so change line 9 to be sell-in.
All right, so now it's going to be unhappy about a few places. It's also going to change our snapshot, but that's okay.
Yeah, it will change. But this I do argue is not a changing interface at this point.
Right.
Right. And we did the work on name to doing those very small steps on name. Got the code in such a way. Ooh, I failed. Oh, the snapshot. Yeah. Got the code. It eliminated all of the knowledge duplication, or a significant amount of the knowledge duplication, so that we can make this change here.
Right.
very easily. So we could do it for quality as well.
Mm-hmm. Yes. Cool. So there's selling. So should we do that with quality?
Yeah, let's do quality. It takes.
I would love to have a refactoring to change like a type alias to a custom type and wire those things for you.
Okay.
Cool. All right. What else should we refactor?
Well, let's see. If we look through, we can see that I don't even, man, I forget the rules for this.
Mm-hmm.
I mean, if I just look at it, I see all of these strings rolling around. So I see, in my first refactorings are things like get the tests going or get the types in there. Start eliminating duplication. I actually don't mind the nesting at this point because I don't have a really huge thing right now. And so if I want to take and eliminate some of the very small knowledge duplications first, I can then come back around and take the next level of knowledge duplication. So there's a knowledge duplication here of strings.
Right. Yeah, and we actually have a custom type. So we could, we actually could make aged brie like a type. We would have to have like a helper that's like string to name that creates the correct variant.
Yeah. Cool. Let's that's a big step to me because that's not eliminating knowledge duplication. That's giving us type state. What I would do is I would take and extract all of the strings into constants.
Oh, nice. Yeah, that's a great step. Should we try that?
That also gives us, that also sets us up to do the thing that you're talking about.
Right, totally.
Because we're now, what does the constant look like?
Right, there's a single source of truth for those names. Yeah, I like that a lot. That sounds great.
And it is this, you can take, when you talk about refactoring with little knowledge of what it's supposed to be doing, you just sit there on iterating between the second and the third rule of simple design. So you eliminate knowledge duplication, you make names nice. You eliminate, make names nice. And you just do this over and over.
Right. Love it. That's great.
And Aaron, I do think that it is a, it feels like it's a kind of item, not a name. And so we can start, once we do this, we now have, similar to what we did when we had name and all of that, is we have centralized that and isolated it into one place, encapsulated it in one place, so we can fiddle with it all we want. Yeah, I think about making the names in units. I would probably like wait and see like what's the best way to do this, because right now it's just eliminate the duplication or eliminate the spread, and then we can, once we have that, we can start looking at what's a good way to fiddle this.
Cool. No more duplication there.
And this is what I think you were saying before, is now there's no knowledge inside of here, so we could actually use that strong typing.
Yeah. Yeah.
Because
it no
our
longer
code
depends
right
on
now
that.
is just doing string. Yeah.
Right.
So we can come in and actually make all of these constants proper type.
Right. Yeah.
It's a larger change.
Yes.
But I'm comfortable. Like, we've already beat the horse of small, like, let's take these small incremental. What we would have to do is we would have to start replacing all of these with is name. Like, we would start to have to replace these not equal to's with a query
to get it into like a case statement or something.
Predicate.
Yeah.
Yeah, with a predicate. So I say let's take the large change, see if we can do it safely, because we have our snapshot test. And age, debris, backstage pass, and sulfurous should return name now.
Should return.
They shouldn't be returned. They should be returned. Not there. Line 34.
Line 34. Okay.
So our three constants should be returning name.
Okay. And then so are we saying that the name is going to be the custom type with the variants? Is that the direction we're moving towards? Cool.
Yeah.
Okay. So these are going to be names like so. This is a bit of a big step, but we can do it.
It's a big step. But it's more, that's it. That's the only change.
Yep.
No, it's not. Yes, it is. No, it's not.
It is not, because create item is wrapping it in name.
Yeah, so 48. Okay, so let's revert.
Yep, revert.
That we just did. It was too big of a refactoring.
Mm-hmm. Let me just check the chat here.
Oh, I like that, Aaron. I like that.
So if you have more powerful refactoring tools, then it's easier to maybe make changes that are too big. Yeah, exactly. For TCR, maybe each auto refactoring should have a point value, and you have to earn points via commits to later redeem for bigger refactorings. Yeah, it's for sure a game. With like the Java or C# tooling, like you can make insanely complex, safe refactorings. And we're getting there with Elm. We'll get there.
So what I would do here is I would actually make an age debris 2. So there's a couple.
We could also have like a create item 2, where the internal ones are creating it with a real item. Like this is really like update. This is like item from the proper types, whereas this is like deserializing an item from raw types.
Yeah, I mean, if instead of create item we did, like update name, update selling, and update quality, or actually we wouldn't even need update name. We would need update selling and update quality.
That's a nice refactoring. Although we have a few places where we're just creating the whole new item. We have a few places where we're returning the quality and then
this is on the left clause.
Adding it. Right. Oh, okay.
That's doing
gotcha.
that quality underscore, which is also a huge red flag.
Right, but we're never changing the name. So actually, that's a and one of the things with Elm is it's really nice when you look at exactly what something depends on, and if we can like take an item and say, here's the item, and here's how I want to change the quality. That's quite nice. So, yeah.
Can we? So let's build an update. Update sell-in. And we're gonna so the question is we took that really big step and it didn't work. So we're gonna take slightly smaller steps.
Totally.
We're not gonna revert back to all of that.
Yeah, you're starting to go up a hill and the engine's, hitting the red marks and you change gears down one.
Yeah.
So okay, so
we have
update quality, but this is part of the public interface.
I would say update item sell-in and update item quality.
So update item sell-in takes an item. So is it gonna?
It should take a sell-in.
Yeah.
So it's really.
It takes a new sell-in and then it updates the item with that. Just to take a little bit of a smaller step, I'm not gonna update it. This is one of the things that you it punishes you for doing a change that doesn't compile or something. So you want to take tiny steps even when it seems silly, which is good, I think.
That's gonna fail.
No, it works. It's just not destructuring.
Oh, you have a case difference.
Yeah. Yeah.
I see. Make the first one new sell-in.
Destructure.
Actually, you just underscore that.
Oh, the old one or the first one's new selling, right?
Yeah, the first one. Use it. And 36.
Okay.
And then put an underscore 35 for the old cell.
It should, yes.
Okay, let's go start using it.
Okay, so, so I guess we're gonna take the sell-in that's passed in, and then we're gonna pipe it through to update sell-in, something like this.
Well, let's just rather than this. I would take even the smaller step.
Okay.
Which is I would just pipe it through.
Ah, nice.
And use
nice. Very nice. And then you'd give it the actual one that you want. Yeah, you.
And then I
What are you unhappy about? Oh.
see.
Huh?
I need to
Oh, it's
construct it. So
destructured.
yeah. So let's create it here. So rapid cell. Yeah. Now let's go write update quality. Yeah, that's true. When you find that small stuff that's even smaller, and you're like, oh, I did it. It's like a puzzle. I love
Yeah,
this.
totally. Mm-hmm. It is. It's
Okay,
almost
so
like calculating a chess move or something and finding like a little tactic. Yeah.
Yeah, so let's write update quality. Do the same thing. I don't want to ripple update item cell in through because I'm not sure that's what I want to do. So I want to just do it at line 110.
Okay.
Because I'm not sure that this is really the right way.
Mm-hmm.
I'm sort of experimenting.
Mm-hmm.
So let me do update quality. And if we can get 110 to look right,
Mm-hmm.
then we can just copy and paste it all the way down.
Mm-hmm. Okay, so you want a similar you want a similar type of deal for update item quality?
Yeah, that feeling when you find the right name. Sorry, I get to have the chat open. Okay. So it takes quality.
Quality. Okay. New quality. And it's going to preserve the cell-in. And it's going to set the new quality. Add a function.
And so if we were taking like a super small steps and not wanting to have unused code, I would do this as a anonymous function that I'm piping into.
Nice.
And
oh, that's
that
yeah, I like that a lot.
Name it.
That's awesome. That's an awesome idea. Very nice.
Cool.
It does give you a certain type of creativity, doesn't it? Just thinking through these small steps.
Yeah, it's this puzzle of, and that would counter Aaron's thing of like we want to have.
Yeah.
It should revert if you have unused code.
Yeah, that's a cool idea. We should try that with Elm Review. I don't know if Jeroen is still on the stream, but we should get Jeroen on sometime and do, if Elm Review fails, then we'll revert everything. Yeah. That would be cool, wouldn't it?
Imagine if that just sort of became like, you know what? We just like, if there's anything wrong, we just revert. Okay, great. Can I always forget all the cases where I can do this, but let's go to the type signature. And for update quality item line 58, can I do that as item?
Yes.
Let's do this. Is it there or is it outside? Do I have another? I always forget where I can do this.
You can definitely do this, and Elm format will, I think, figure it out if it needs parens or not.
What happened? Oh, that's the diff. Okay. Awesome. Let's go down to there and replace that.
Good call.
And now we've gotten rid of it.
Nice. Great. Very nice. Very nice.
And if we had wanted to do this with a smaller step, I would have extracted it into a let in the if.
Love it. That's awesome. So do we want to try applying this to some more stuff?
So we should be able to now ripple this. Yeah, we should be able to easily ripple this through.
That's awesome.
Oh, wait. Update item sell-in. I don't like that. We have to
wrap it.
Wrap that.
Totally.
So there's a couple things we could do. Let it take an integer and wrap it inside. And then we can roll back And so we can take cell in, move that into the function, let the function take an int, ripple this pattern through everything. And then we can go up to where cell_in underscore is defined. And do that. Let's do this.
Okay.
This is going to be actually really a great
Cool.
thing. So let's take and get rid of this cell_in, change update item cell_in to take an int. And then wrap it here.
Oh, I just saved.
Okay. That's okay. Let's just do it again. We're taking bigger steps than we would.
Okay. And then I need to make Intellij not save. What's that?
Go down to where we use it. Get rid of it. And then we should be able to save this now. And let's do the same thing for quality. This is why I didn't want to ripple it through.
Right. Experiment to get feedback.
Yeah, if I like it, so now we do quality.
Oops, I saved. Oops, I did it again.
Okay. Now let's ripple it.
Cool. Sounds good. So.
Yeah, I can see that there. It says that it's making him think of 2D strategy games where at first you had to manually move left, up, right, but now you can just click your destination and the game auto pathfind. Maybe some similar future is in store for the TCR set. Yeah, I think so. And it is that sort of a game. On line 120 is now item.
Yeah.
At this point, you can line 120 through 122 can replace line 125. Quality minus quality is zero.
I would agree with that. That's generally true of subtracting numbers from itself. Maybe if it's infinity, I don't know.
Perhaps that was a little bit. Okay, so let's take 125 and 127 and replace 136 and 139 because that's 125.
Cool.
And then we have two last ones, 130 and 133. Quality 0. You know what? Wait. We've done a lot. I want to make sure that we get a failure. So change that 0.
Challenge accepted.
It's been a long time since I've seen a failure.
There we go. There are those beautiful failures.
Okay.
Lots.
I never.
Yeah. Lots of failures.
Okay. So why didn't that? Oh, there it is. Okay. Great. So now we can come down and do this last one. Aaron, what do you mean that now items have a default quality in selling? They don't. That this item comes from what's passed in. This is the thing that's passed in.
Yeah, selin is defined in the let.
Yeah, so we don't have defaults yet. An item is not default item. It's the thing that's passed into this function.
Okay, so oh yeah.
We're almost to the point where we want it, why we're doing all this,
Yes.
which is we want update item selin and update item quality to take a selin. But here's the problem. We can't have it be selin underscore because notice line 110, we're doing all of these. So we still have...
should we do something like this?
No, let's just be comfortable with what we have right now. We don't need to... so let's just leave it as taking an int for now, because we need to do a little bit of adjustment. To do it. So now all of this has just been eliminating, duplication.
Yep.
Better names for the updates and stuff. So now let's look at some of these nestings.
Yeah.
What are these? If quality is more than 0, quality is less than 50, this thing, line 73 through 70, whatever, it's kind of confusing. Oh, I see why. 75. So here's a naming issue. 75 to 98. It's poorly named. So this is... So what we have is a situation where... Okay, so it's if selin is less than 6 and quality is less than 48, then it's a 1. Otherwise, it's 0. So let's make that change here. On line 80, I'm sorry. On line 80. Let's start on the side and move outward.
There are also some interesting techniques that can come in handy for cases like this, where you can essentially like extract this, wrap it in a like you can duplicate it into an if else, and then duplicate an if condition that's in here and then use code coverage to prove that you are that you're hitting a clause that is redundant. But that might be a topic for another day. But okay, so you were...
I'm just saying let's collapse this. So nested ifs.
Okay. Cool. So
it's if selin is less than 6 and quality is...
And that's less than 48. Then this... then it's 1. And our tests will support us, and they say it's okay.
Okay, so now we can, look at that. If, so we should, if selin is less than 11 and quality is less than 49.
We could also collapse this guy, this 1 plus, into here. So we could like take this 1 plus and duplicate it into both clauses. You see what I'm saying? Like this?
No, we can't.
Really? Well, let's ask the tests.
Oh, you're saying a 2 and a 1. I see what you're... Oh, I see you're putting it in there. Yeah, that'll...
And then we can just rewrite these guys.
And now we can collapse 76 and 77.
Mm-hmm.
One of the interesting things about doing a refactoring like this, where we don't have the rules in our hands, we're just like doing code stuff.
Mm-hmm.
It's we run the what we're doing is we have no concept of the domain that we're working in.
Mm-hmm.
We don't know what our domain rules are, and so we very easily could write code that is it's not understandable.
Yes, exactly.
From the point of view of a domain expert. What we're doing is we're effectively running into the same problem as like evolutionary algorithms,
right?
Where we're just kind of like randomly doing stuff, and then you look at it and it seems to work,
mm-hmm.
but
yeah, one of the biggest mindset shifts that I went through, learning about test-driven development and evolutionary design and all these types of principles, was the idea that like traditionally people think that you have to understand the code so you can refactor it, but I started realizing you have to refactor the code so you can understand it. And
because when you run back here, you can see that.
Right, and that requires a certain. So I mean, that requires changing your approach to refactoring, where you're doing tiny steps that are automated or, very obviously safe, with guidance from tests. And when you do that, you can flip that mindset. But if you don't do that, then people do this thing that's in a lot of people's comfort zones, which is to think really hard about the code, make sure you understand it, and then rewrite it with that understanding, trying to preserve the behavior that you've mapped out in your head. It's a lot harder. It requires a lot more thought.
Yeah. Well, let's ripple that plus one.
I was just looking at that. That sounds great.
Follow along with what you had done before.
Little arithmetic. I won't be too dogmatic. I'll directly increment those. Oh yeah, they seem to be protecting code. Yeah, so Wonderful is saying the 48 and 49 seem to be just protecting going over 50, which is a perfect example of this idea that we need to refactor in order to understand. We get clarity. It's like it comes into focus as we refactor.
That's a really good insight.
Whatever. Okay, my new commit message for this is math. Cool. What else do you think we should do here?
So backstage pass. So why is so let's look at that line 74. What is that back? So we know at this point.
Mm-hmm.
No. Okay. No, we don't know that it's backstage pass. What? Let's read through that code and understand what it's doing. It's saying that my quality. If name is backstage pass, so quality. We're only really. We add one. Backstage pass can go above. Backstage pass only adds.
Yeah, there's some logic where backstage passes increase as it gets within a certain range. They increase more quickly. Like, hey, the concert's in 3 days, or whatever it is. But then after the concert, it drops to 0.
Okay.
which there's some logic for somewhere else.
Yeah.
Yeah.
Okay. So sulfurous never changes
That's right.
its quality. Okay.
Right. And now, so there's this interesting thing where this code is super coupled in to this nesting, where we're checking for lots of different conditions all at once, instead of saying, if it's sulfurous, this is how you handle it. If it's a backstage pass, this is how you handle it, right? Which is what we like to do. Like, ideally, it would be like a case statement, and then it's like, for sulfurous, change the quality like this, change the sell-in like this, you know? But so it's tricky to like restructure it that way, because it's sort of locked into these places. So that's yeah, that's where some tricks can come in handy, like using code coverage if we sort of duplicate some of these cases and see cases that are not being hit.
Yeah. So we could do that invert. We could take name. We could take a refactoring that makes those comparisons not comparing.
Mm-hmm. Yeah.
I would probably take our names, all of the comparisons against name,
Mm-hmm.
and I would replace those with predicates. So instead of saying name does not equal aged brie, I would say if not aged brie, and I would pass the item.
Mm-hmm.
And or I would so I would put like a not. So I would say is aged brie.
Mm-hmm. What I wonder is, does that like take us down a path where we're more coupled to this structure of nesting, which we don't really like?
How so?
Because like what I picture is like a structure that's more flat, where it's just like more clearly stating, this is the logic for aged brie, this is the logic for backstage pass.
Oh, I see what you're saying.
So does this take us deeper in a path that's not in that direction?
I mean, it doesn't have to be, because you can just say if is aged brie, else if is backstage pass.
Mm-hmm.
You want to do a case statement. It's honestly, to me, 6 of one, half a dozen of another. Whether we do a case statement over constants or ifs over function. Either way, do you want to?
I'm definitely tempted to somehow take a step that gets us away from the nesting, because at this point, that's the thing that is like very, very tricky to read.
So if we had, so let's, I can't. It's not that bad to move from a if else if to a case.
Sorry, I was reading. Reading Odmund's comment. What did you say?
Let me read.
So he's saying, Dylan, is that where you surround the whole thing with if name equals backstage pass and duplicate the function in both clauses? Exactly. And then check the code coverage for unreached code. Yeah, so that's a trick. We can try it. It's so basically like if we literally just duplicate that, like, so here, should we just try this? We can always revert if it doesn't go well.
We don't need to do selin.
Yeah, exactly. Just
show
for
the example of selin.
Sounds good.
Selin is much smaller.
Yes, sounds good to me. Okay, so
Wait, line 92.
line 92. Well, we don't have any nested ifs for line 92, so that it wouldn't help us here. So the it's easier to just show here because we like this isn't nested, so this wouldn't give it to us. So what it would be is so like let's take this quality equals. So let's try this. So what we'd say is if true. You know what? I actually have. Oh, okay. Let's take a moment to make sure. Do I have this set up? I might not have this set up right now. Live template. This is the perfect case for live templates because we can have a very safe live template. Do I have my if live template? I do. Okay. So check this out. Like I can do this. Here's my if live template. This is what it does. It just wraps it with if true. That's always safe refactoring, right? Yeah. So IntelliJ, I've set up my IntelliJ with this little handy helper. Let's see if it works on this big chunk of code here. And if there's any problem, it will just complain. But so if true, is it still the same? Yep. So wrap in an if true. So that's equivalent, right? Now, if we're doing an if else where the if and else body are exactly the same, then we can say if name is aged Brie, for example.
Okay.
And that we haven't changed any behavior. Change if condition. And now, this is the fun part. We can run the code coverage. Oh. Did I do something wrong? Or maybe this is... aha! Check that out. So if the name is aged Brie, and the name is not... if the name equals aged Brie, and the name is not aged Brie and is not backstage pass, that's always going to be false. So this is dead code. We've just proven that this is dead code. So we can now delete this whole clause.
Okay.
Cool, right?
Neat. Yeah. Okay.
So this is not a guess. This is we just proved that. And our tests still pass. Cool, right?
Yeah, that is cool.
So delete, we're just deleting unused code. And here's more unused code. Isn't that cool?
That is cool.
So I have to give credit to Llewellyn Falco for this technique. Llewellyn gave a really cool talk that inspired me to experiment with building a prototype for this snapshot testing, this combination of TCR, snapshot testing, and this trick to remove the nesting of the ifs. So actually, I've been on a path where I've been building a lot of tooling to help basically reproduce the techniques that Llewellyn uses for that talk in the context of Elm. So it's been kind of fun. Yeah, Odmund's saying he saw him do that talk. It's a really cool talk. Let me send a link to that. Where did you go? There's my window. Let me send that path, that YouTube link. Yeah, it's a very cool talk. You will notice a lot of similarity to what we just did in this talk. Well worth a watch. Here's the link. Definitely check it out. Let's see, was somebody saying, I think Justin's saying, would you mind talking about that technique one more time? Yeah, no problem, Justin. So
I'll be back in a second.
sounds good. So the technique is that we take, so we can it's always fair game to take an expression in Elm, especially in Elm, right? Because with Elm, there's no chance that a refactoring will perform side effects. So in Elm, you can always safely wrap any expression in an if. As long as the body of the if and the else are the same, they're always the same. And if the if and else body are the same, you can safely change the if condition to anything you want. I could say if banana equals monkey, then do this. It doesn't matter. Like, it's although I'm not going to commit that, I will revert that. But it's never going to change the code because you're following the same paths whether the if condition is true or not. So you can always safely do that. So what you're doing is you're using that to help you with code coverage, to detect redundant, to flatten your ifs. So you're like pulling things out of if clauses using that technique. It really hurts to wrap your brain around it, but that's all I've done. So what I did is I used that. I created a live template in Intellij. This is a live template. I'll like share this on Twitter, but this is all it is. It just literally surrounds the selection and duplicates it to the body of the if and the body of the else, and then lets you type in a condition which defaults to true. And then you can type in any condition you want. Then you look at the code coverage, you see dead lines, and you can eliminate it. So in a way, you're pulling those dead lines up. Because what you're doing is you're not just doing any random condition in your if. So in this case, I did if name equals aged brie, which led us to delete something where it was never true. If name does not equal aged brie. Well, we just said if name equals aged brie, but it can't equal aged brie and then not equal aged brie. So we created that duplication. So let's see where our... can you package live templates with IntelliJ Elm? Cool technique, right? Aaron's asking, can you package live templates with IntelliJ Elm? You can, and there are some built in, and that's another pull request I'd like to make to IntelliJ Elm. Yeah, totally. Because this is a solid one. It works perfectly. It's provably safe, super simple. Okay, so here's our latest coverage report. Okay, so here's some more dead code. We can just delete it. So if name equals... okay, so notice here. If name equals backstage pass, then, well, we just said if name equals aged brie here. So now we can kill all of this. So...
ends up being a 1.
If name equals backstage pass, then this is the else, right? Yeah.
Yep.
So we can delete this. We've just proven that that's dead code. Simplification of that could easily be added to Elm Refactor. I'm kind of excited to add that to my backlog. Nice, Aaron. That's interesting. The simplification because you can statically analyze the code and see if conditions that are contradictory. Yes, exactly. Right. And we're using a little trick with our tooling to not make us think too hard because our static analysis isn't perfect. But if you can have a tool that does the static analysis, then you can skip those steps. Yeah, that would be awesome. Okay, so let's see where we are with our coverage. I think we've just removed all the dead code for that pass. Oh, there's one.
Yeah, because
if the name... What is this to? If name equals backstage pass.
Oh, we know, like, let's get rid of line 69.
Yes.
We can get rid of, we know that name does not equal page degree.
Right. So this is false. Right. If I do this, then
no, it's
we
true.
can ask this is the nice thing is we have 100% test coverage, so we can just ask it, and it's like, no, Dylan, you're wrong. So
it's true.
True. Nice. And true end is the same as that. That's a tautology. Is it always backstage pass? If name does not equal backstage pass, let's look at our report and see where we are here.
That's what was missing there. Is that one is, yeah, we know that it's always backstage pass there.
Right. Which is this guy right here, right? It's always backstage pass. Mm-hmm. Cool.
That condition.
Cool. Remove dead code.
Nice.
So I think we should I think we've gotten rid of all of the dead code right now. We can use that technique again. What do you think, Corey? Should we try that another time? Should we try that one more time?
Yeah, I actually have to.
Okay, totally. We've gone like way over, but this was too fun. So.
But the one thing I would do is line 80.
Yeah.
We have I would not have the else if quality less 50 be on the same level as name checks.
Else.
So I would like line 80, I would split that into an else and then the if on the next line. And then get rid of 94 and 95. Because I don't like if else ifs to me should be at a level like a case. That's a personal style.
What am I doing wrong here?
Line 81 was to hit into there.
Yes.
And then I think line
indent, and then I should indent all of this.
Yeah.
And then this goes like this.
Yes. Oh, and Elm format brings it back to it.
Aaron, just joking.
Aaron.
Corey doesn't like your style, Aaron. That's too funny.
Hilarious. That's okay.
I love that Aaron's in the chat, so we can tease him about that, though. That's great. I'm okay with the style. Everybody's got their own preferences. Okay, cool. Well, I think let's wrap it here. Just maybe some parting thoughts. But this was so fun. We could like go for a bajillion more hours and keep having fun with this. But this was great. Thanks so much for coming on the stream.
Yeah, thanks for having me. This was a lot of fun. It was I love doing these like little tiny pedantic
Yeah, me too.
steps.
It's great. It's so cool to just like explore, and to anybody, you know, wanting to play around with these techniques, it's all about exploring. You know, it's all about just having fun with it and try an extreme way of writing things and see how it feels. You don't have to do it forever. You just try it once, see how it goes.
Yeah, one thing I like to say is that
Yes.
this is not how you should program,
Yes.
meaning
Right.
with these small
Right.
steps.
Right.
But I do believe this is you should know how to do
Exactly.
this is a good
Exactly.
technique.
Yes.
I would also like to point out
Mm-hmm.
my cat
That's amazing.
here that are
Very
hanging out. There's the
symmetric.
two cats
I love
here.
it.
So
I also want to thank everybody for joining, and also super fun, Odmund, that you joined the stream. Maybe if you're interested, we can do a stream with you and explore some more TCR stuff, because I think this is a really fun topic, and it's really interesting in the context of Elm because it's purity. You know, I've been playing around with some Kotlin, working on some contributions to Intellij Elm, and I notice in the refactorings that if there's like an unused variable, you hit the shortcut key to do a safe delete. It's like delete this variable. And you're like, oh great, it's not used. Delete it. It deletes the declaration of the variable, because the value might have some side effect. You don't know. But with Elm, there's just so much confidence you can have when you're going through and doing these refactorings. And so pairing it with these different techniques and exploring TCR and these different techniques in the context of Elm is so much fun. So again,
yeah, and I love these small, tiny steps. You have to do slightly different things when you are in a type system.
yes.
And so you can't, like I do this all the time. I actually do a lot of this small steps when I'm building Ruby, and you have a little bit more freedom. You don't have to have everything line up as long as just code gets the end result that you're looking for. But it would be fun to do this sort of thing on a new project where we are using the technique of you can't have unused code. And so,
that would be really fun. I'm definitely gonna invite Jeroen onto the stream. I'm sure he'll be all about it to try TCR in tandem with Elm Review, and Elm Review failures just revert your code. I love that. That sounds super fun. We've got a couple points here. Odmund is saying TCR feels very different in Elm and Elixir. Yeah, and Justin's asking, Corey, what's the part that you shouldn't program like that we were doing today?
Oh, the like super tiny steps where you're like, okay, we have to make one change and that's all we're allowed before we run. Like
right.
It impedes progress.
Right. But if you don't know how to do it, then you get into a tricky situation and you just flail, as you were talking about. Yeah.
Yeah, because like what we did was there was a time where we said, oh, let's not do that. Let's take a big step, and then we didn't know how to take the big step, or other parts of our code that create item down at the bottom or where we have that item, that our step was too big.
Yes.
And not the motivation, but our instinct, I said this before, is to go fix that part. But the instinct, if you can switch your instinct to be, let me revert and take a smaller step.
Exactly. Right.
And eventually you hit a point where you're like, I don't know what the next smallest step is, but there's almost assuredly a next smaller step that you could take.
Right.
And that's what I mean by you shouldn't start off with those tiny steps, but if you know how to start off with those tiny steps, then you're never going to hit that wall as you're cutting back.
Right. It's very zen. Because it doesn't allow you to be attached to the step that you've partially done, because you get a clean slate if something goes wrong, and you're just like, maybe I should try a different direction or take a smaller step.
Or when you're like, I've got to fix this, and you fix that, something else breaks, and then you start playing whack-a with all of breakages. And the beauty of having a compiler have your back is that eventually, you'll fix it all.
Yeah, right.
Because the compiler is going to not let you not fix it, but it's going to take you time and it's frustration and it throws you off and you're just like, as opposed to just revert, take a small.
Right. It kind of makes me think a little bit of, there's this app I really like to use for drafting like articles and stuff. And it's called Flow State. And what it does, have you ever used it?
I've used it, but it's
it's intense. But the idea is really cool, which is that if you stop typing for more than 3 seconds or whatever, then your text starts to fade away, and it disappears after a few seconds. So what it's trying to do is it's trying to program your brain to keep moving and typing, keep your fingers moving, because what tends to happen, the underlying idea is we tend to get caught up in playing the editing role when we should be drafting, just getting ideas out there. And you can't effectively do both at the same time. You get paralyzed. So you need to just keep moving and get the ideas out there, and then you can always come back and edit. I think that TCR is actually very similar, that you just, it's okay if you don't know exactly where you're going to end up, that's okay. But just try something that keeps you moving. Because what happens is we try to do big steps and we're like, I want to make sure I take the right step. And you get very attached to figuring out the right step first and you overanalyze it and you get stuck. Or you try to do steps that are too big. Just take a small step, see how it goes, keep moving. And it's okay if you we did this several times, that you try something, you introduce a type and you're like, you know what, delete that. And then you delete and it's another commit and that's fine. So it just keeps you moving when you, as you're talking about, you have the ability to downshift into a lower gear so you can move through tougher problems. So,
Okay, yeah.
We could talk for a million years, couldn't we? I know, this is too fun.
I could talk for hours about steps and small
I know,
steps.
it's too much fun.
Refactoring and all of that.
Yeah, but this was so much fun. Thank you, Corey.
Yeah, this was a blast.
And thank you everyone for joining. And thank you, Odman, for chiming in. That was super fun that you joined the chat. I'm looking forward to chatting more. And thanks again for coming on, Corey. This was a lot of fun.
Thanks, everybody. And we'll... I'm streaming tomorrow too. If people want to jump on.
Very cool. What time?
I'm working on it. I actually don't know.
That's okay.
Probably. Oh wait, no. I'm doing it after Aaron. Aaron, when are you doing yours? Is at 10 a.m. Pacific, and then I was planning on doing it right after him. And I'm just gonna.
Awesome.
I've got I play a game called Can't Stop, which is this dice rolling I played on Board Game Arena, and there's a counting strategy to tell you when you should stop your turn, because you keep rolling dice until you can't move or you stop, and there's a counting strategy for when you should stop. And I was going to write a little app that lets me just put in my rolls as I'm going.
Yeah.
And then it'll tell me, you should stop.
Awesome.
So,
awesome.
Just a little. I'm going to be, eventually I'm getting to where I have a whole upgrade I want to do for a side project. But I keep just doing all little.
Great stuff. Well, definitely follow Corey on Twitch if you aren't already. And
Do, please. So it's right after. I'll be in with Aaron with the puzzle stuff.
Awesome.
And then once
maybe Aaron can raid your channel.
Yeah. he raids my channel. He raided my channel Friday, and then everybody left. It'll be fun.
Yeah.
Okay.
Great stuff. Thanks, everyone. Thank you so much, Corey. This was a blast.
Bye.
See you later. Bye.